Hey there everybody, and welcome to part 7 of the upbge tutorial series where I teach you how to make video games using the Blender game engine. That is a fucking title. In this part, I want to build off of what we did last time where we added coins that attract to the character, the cube. I want to build on that and make the coins look aesthetically more pleasing, and I don't mean that in terms of materials or anything like that or modeling. I just mean the coins should spin over time, and as they get close to the cube, they should kind of snap to it. Instead of just moving towards it, it should start slow and then accelerate, because this will make it more satisfying to play. So where we left off of in the last part is we have a cube, you can move it, and it collects coins when they're within some proximity, but it's kind of boring. So let's fix that. I'm going to start off by actually deleting every coin except the first one, and you're asking why would you do that? Because when you change something here, it applies to all objects that have that node network. It's because of a bit of a technicality. When I modeled this coin off of a cylinder, I kind of did some rotation to begin with, which is going to be an issue. You're going to see the rotation set to -90. Just hit Control A if you modeled it like I did and apply rotation. Make sure that the rotation is zeroed out, so when we say rotate on the z-axis, it actually happens on the z-axis, not the x or the y. Our orientation is correct. Just a bit of a technicality. And now we can actually apply some extra stuff to this. What I want to do is I want to have this coin spin, rotate on every frame. To do that, we kind of already know how to do it. We're going to go to Object, Transformation. Basically everything we've done has been some kind of physics or transformation. We are going to apply rotation, which we've done before when we had our character move left and right, or turn left and right with A and D, but now we're going to do it a bit differently. I want to apply a local rotation to the object, so to yourself, to the coin, on the condition of all the time. So in other words, on update, on every single frame, every single update, apply a rotation. And that rotation should be, I guess we'll play with it. Let's try 1 degree. So that's actually a very slow motion, and that looks pretty good. You could have it be 2 degrees or whatever. But you can see now our coin is perpetually spinning, and it still gravitates and deletes itself. I'm going to actually have it go 50% faster at 1.5 degrees. You can play around with this. Maybe actually 2.5 degrees. I want it to be like fast, but not too fast. That looks pretty good. And now we have the thing rotating. Because this has been applied to the node network, I can now add a bunch of coins. And as you might expect, when we hit P, now they're all rotating. Except they kind of look weird because they're all perfectly in sync. So another thing we can do visually is to add a bit of offset. So not every coin starts with the same rotation, so they're all a bit out of sync. Okay? To do that, again, we're going to apply a rotation locally on the condition now of initialization. So remember, I think we used initialization. If we haven't, what it means is this condition will only be true the moment the game starts, and then it will not be true ever again. So only on initialization, only when the game starts, apply rotation to the object of, we're going to use a custom vector. So instead of just like plugging something into the Z, we want a random number. Each object should have a random number. So we can type in random, and we're going for a random float. So a random number between 0 and 1, or anything with decimals. A random float on the Z-axis between, like, let's say 0 and 2 pi. The reason I'm saying 2 pi is if this takes radians, I'm not sure if it's degrees or radians, I always forget. This would cover the whole domain. But either way, what we're doing is we are going to say make a random number and apply it to the Z. This may or may not work. Let's see. They all look in sync. And maybe this is because it's too low. Let's see. I'm making it between 0 and 100. No, that's not the issue. They're all perfectly in sync still. What we want to do is we want to say initialize, or not initialize, actually create a random number, because it doesn't seem to be doing that. So you can apply the condition. However, now they are offset, but I believe it's going to kind of, I don't know if it does it on every frame, but I guess as just a safety, I'm just going to do it on initialization. So right when the game starts, it's going to generate a random number so that they are out of sync. And just to make sure, I'm going to make it 360 in case it's in degrees. But now you can see these are out of sync, and any coin we add will inherit this property. Okay? So they're rotating, and they're out of sync, and they're still gravitating towards the cube, but they're kind of gravitating towards the cube in a pretty boring way, right? They're just doing a linear velocity. And by that I mean they go at the same speed once they're activated. I want it to be kind of acceleration-y. And you can do this with physics, or you can fake it, which is what we're going to do. And you might ask, why not do it with physics? Because this is how we're doing it, you know. You could do it with physics, and then it would actually interact with the objects, but this is fine. So remember, we're checking the distance between the coin and the character, and once that is hit the condition, we do a bunch of things. We move it, and we remove the object. But instead of checking the distance, now I want to actually compute the distance. So checking distance does it internally, but it only outputs a conditional. When we actually use the distance node, we can take two objects and calculate the actual distance, the actual number. And notice that we're only activating our coin. It's only going to be moved and removed once the distance of 5 is reached. So I have to be within 5 units. In other words, the distances we care about are anything between 0 and 5 in this case. So, a bit of complicated math here. I'm going to take our distance and divide it by 5. So remember, all we care about is anything between 0 and 5. So when I divide this by 5, we're saying we only care about 0 to 1. But now I want to reverse this, and you'll see what I'm doing in a second. I know it's a bit not explained at the moment. So I'm going to reverse it. So instead of going from 0 to 1, it's going to go from 1 to 0. That's what 1 minus is doing with the subtraction. So now we are going not from 0 to 1, but 1 to 0. And I want to take this and then multiply it by some number. Okay? So I'm going to take this and connect it to the speed, and I will explain what it does in a second. So when we are within 5 units, you can see the coin is moving, but this time much more slowly. Which is not what we want. But you could see definitely what we did has affected it. What's actually going on here is on every frame it's going to compute the distance, and it's going to change the speed that it moves to our cube accordingly. Okay? So what I'm saying is when we divide by 5, when the thing gets activated, it's at a speed range between 0 and 1. I'm flipping it so that it starts at 0, and as it gets closer and closer and closer to the cube, it's going to increase. And now I'm going to multiply it by a bigger number, like 25. And let's see what that looks like. So you can see now the coins are moving, but if you kind of notice, that it's kind of accelerating. Like it feels a bit more, I don't know, a bit more smooth in a sense. And that's exactly what we're going for. So now there's a variable speed. In other words, an acceleration. One other thing I want to do is you can see it's a bit glitchy when it gets close to the cube. It doesn't delete itself immediately. And that's because our stopping distance is too low. So again, we're saying when you're within this distance, then remove the object. So this should make it look a bit better. And you can see that this is a bit snappier. Like it feels like there's a magnet attracting it. And if you wanted to take this to the next level, which we might, let's see what it looks like. Remember, we're going from a 0 to 1 or 1 to 0 interval here. Which means if we take this and raise it to the power of 2 or 3 or whatever, it's still going to be contained between 0 and 1, and then we're going to multiply it later. So we're kind of changing the fall off from a linear to a quadratic to a cubic, okay? If you don't understand this part, it's just a bit extra. So what I want to do is I want to see if there is a power function here. If not, we can do it ourselves. So what I want to do is have a to the power b. Yep, a to the power b. So now we have this thing squared and then multiplied by 25. So all this is going to do is it's going to do the same thing, but now you're going to see it starts slow and then it goes very fast as it gets closer. Now, the thing is, that looks very good, except it only activates when we're like too close. So I'm going to increase the distance to 8, so I'm going to increase that accordingly, and let's see what that does. There you go. So now they are activated at a long range. And they can be like deactivated if I move far away from it. And they're a bit snappier. I feel like that looks a lot better. And they're rotating, and there's random rotation. You could also have them like scale down, which I don't want to do yet, but it is something you could do. So it's almost like it's collecting it. But that is a bit more complicated because what happens if I move towards the coin and then I back away? Does it stay like shrunk? Bit of an issue there. So that is how we're going to make our coins more fun. I guess another thing we can do is we can add a sound effect and all of this to make it, you know, more charming. But at this point, we should just be able to add coins anywhere in our game, and it's going to follow our rules. So now you can collect them. I guess one thing we should probably work on next, other than the scaling thing, is we should probably have a counter for how many coins it's collected. So there you go, more satisfying coins. See you in the next one.